Welcome to Wave Surfer, using the Thermal Analysis System software, training video. In this training video, you will learn how to use Wave Surfer with the Thermal Analysis System, or TAS, to objectively evaluate wave solder machine performance in a consistent and repeatable way. This video focuses on running Wave Surfer profiles using the TAS software. If you have already seen our TAS overview or SPS profiling videos, this session builds on that foundation and shifts the focus specifically to machine performance validation for wave soldering. Today's customers expect detailed, objective data when commissioning or maintaining equipment. They want confidence that the machine itself is performing correctly, not just that a single product passed inspection. That is exactly where Wave Surfer comes in. In this general overview of the Wave Surfer, we begin by explaining what the Wave Surfer is and how it is used to validate wave solder machine performance. We then review the Wave Surfer hardware and its key components, followed by an overview of the software configuration using the Thermal Analysis System, or TAS. This includes setting up the profiler and configuring the TAS software specifically for Wave Surfer profiles. Next, we identify the wave solder machine components and explain how preheat zones, solder waves, and conveyor set points are defined and established. We also introduce the process window used for Wave Surfer measurements to complete the software setup. Once setup is complete, we run a Wave Surfer profile through the machine and review the results. Finally, we analyze the collected data and discuss profile optimization based on the Wave Surfer measurements. The Wave Surfer is a smart fixture designed to check and validate wave solder machine performance. Unlike traditional profiling, which focuses on a specific printed circuit board, the Wave Surfer provides a consistent reference for evaluating the machine itself. Wave Surfer is compatible with most wave solder machine models, making it suitable for a wide range of production environments. The key takeaway is simple. Wave Surfer helps answer the question, is my wave solder machine performing as expected? Now, let's take a closer look at the Wave Surfer hardware. Wave Surfer is built on a Durastone pallet combined with titanium and stainless steel components. This construction makes the fixture durable enough for thousands of runs through a wave solder machine. Wave Surfer does not include a built-in profiler. This allows compatibility with 6, 7, 9, and 12-channel profilers. The fixture includes 5 embedded thermocouples designed to collect wave-specific data. It also includes 2 sample printed circuit boards, 1 low-mass board and 1 high-mass board. These boards are used to collect meaningful data in the preheat section of the machine. This hardware design ensures consistent and repeatable measurements from run to run. Wave Surfer profiles are created and run using the TAS software. To get started, you'll first set up the profiler and configure the Wave Surfer fixture, as shown here. Next, you'll define the wave solder machine in the TAS software by entering its physical dimensions, preheat zones, solder wave locations, and set points. Taking the time to define the machine accurately is important. It ensures the data you collect reflects real operating conditions and helps deliver consistent and repeatable results. To help with this step, video examples shown here will walk you through identifying and measuring each machine component. Once the machine is defined, you'll create a Wave Surfer specific process window. This sets clear performance limits and provides a consistent way to evaluate the machine. With these steps complete, you're ready to run the Wave Surfer profile. Each Wave Surfer profile captures data from embedded thermocouples, allowing us to evaluate critical parameters like conveyor speed, preheat ramp, wave dwell time, parallelism, and solder pot temperature. Once the Wave Surfer exits the wave solder machine, remove it from the conveyor and place it in a secure location. If the wireless feature is enabled, the profile will automatically download once all required conditions are met. When profiling in data log mode, connect the profiler to the PC running the TAS software. When fully downloaded, the Wave Surfer profile will be ready for analysis. Note that the TAS software displays a profile graph that is divided into preheat and wave sections. This visual shows how the temperatures are delivered through the process, from controlled preheat to direct wave contact. Each thermocouple temperature plot on the profile graph represents a different measurement point from the wave surfer fixture. Analysis begins with preheat performance. In the statistics tables, TAS summarizes key preheat metrics such as ramp rate, soak behavior, and peak temperatures. These values help confirm if the results of the wave surfer measurement are sufficient for meeting our machine and process requirements. For example, flux activation, while avoiding thermal shock and ensuring proper topside board temperature before the board reaches the wave. Next, we analyze the wave section, which is the most critical part of the process. Wave-specific metrics include dwell time, wave parallelism, solder pot temperature, and conveyor speed. To summarize overall performance, TAS calculates the process window index, or PWI. PWI reduces a complex thermal profile into a single, easy-to-compare value, making it simple to determine whether the process is inside or outside specification. This allows profiles to be compared over time, helping track machine repeatability, identify drift, and support quality assurance. In summary, downloading and analyzing a wave surfer profile allows you to validate wave solder machine performance. Using the wave surfer, you can capture real-time thermal and wave height profiles and compare them to process specs. This confirms correct conveyor speed, solder contact time, immersion depth, and overall machine consistency, providing objective, data-based performance verification instead of guesswork. Confirm preheat and wave stability. The wave surfer captures the actual temperatures achieved during the preheat stage and records the behavior of the chip wave and main wave. By analyzing these graphs, you can verify whether the PCB reaches the correct thermal soak, ensure that the wave is stable, and confirm there are no fluctuations that could cause solder defects. Detect changes before they impact production. Because wave surfer data is consistent and easy to follow over time, it helps you spot small changes that operators might miss, like slow heater drift, nozzle problems, pump issues, or changes in conveyor speed. Finding these problems early lets you fix them before they cause defects, reducing scrap and rework. This data-driven approach ensures consistent quality and confidence in your wave solder process. This concludes the Wave Surfer with TAS software training video. Thank you for watching this video. If you would like more information on our products or have any questions, please go to our website kicthermal.com. Thank you, and we appreciate your business.